Good morning, one and all. Uh, Today we are going to discuss theory and model for human-computer interaction. Myself, Dr. P. Krishnamurthy, Associate Professor, PG Department of Computer Science, Tritangalnada College, Chennai. Uh, the today topic is more interesting and efficient one for all of us. So the agenda is what is theory, what is model, perception, action, cognition, behavior, interaction, and software architectures. Those things we are going to discuss today. So first thing is we are going to discuss what is model. So model is a simplification of reality. That is we are going to achieve one task. So that is here goal, abstraction of the reality, conflict between precision and generality. Choose the level of abstraction. Here the goal is to be useful for us, and similarly non-relevant things we are going to omit it. And then next thing is we are going to take up power of the model. The power of model here we are specified three ways. So one is descriptive, predictive, and generative. So descriptive is we are represent the phenomenon, that is in aspects of the descriptive. So second one is predictive. So anticipate the behavior we are going to fetch it in that model. And similarly generative, so imagine new solution to a problem. So we are inheriting or generating on new things. In that these three things are we have a power of model. Then notation. So notation is a description of a language. It may be a informal or incomplete or inconsistent. So that is here an example given, user action notations. So first thing is we are going to discuss more what is theory. So theory is an explanation for a particular model for a object or a thing. So that is here we are specified the valid one, not only for the prediction of the model but also model itself. So here falsibility things, that is swappers. So scientific theory must be disprovable through experiments. So we are going to explain experiment with the basis on some experiments. Falsibility theory can be refined into a better theory. So here an example, Newton so introduced how the apple has fall down. So Einstein calculate the relational between the object and earth. So the distance and then measurements are calculated. See here an empirical law equal to observation of a regularity without explanation. So here the next one is perception and actions. Here different authors are specify pre-attentive perception, ecological theory of perception, Hicks and Fitts law, and kinematic chain theory. So pre-attentive perceptions, human can recognize some specific features. For example, line, length, thickness, size, curvatures, cardinality, intersection, inclusion, hue, blinkingness, movement, direction, depth, etc. See here, some interference when combining such things are here, like a line orientation, thickness, length, size. See here, pre-attentive perceptions, parallel handling at the level of visual perceptions. Perceived pre-attentively must be handled sequentially with the link of Gestalt theory. See here an example for object. See horizontal as well as vertical objects here we are represented. All the objects are in dot shape. See here we are going to select horizontal as well as vertical objects. Some deviations we are going to take in. So based on the Gestalt perceptions, here we are going to take a principle of Gestalt perceptions. Common area, the common area specification is without space in horizontal as well as vertical. We are here specify in the first thing, and the second thing is then the common area here we are specify. The second thing is proximity. The proximity here we are specify some space, maybe in horizontal as well as vertical, we are going to take up a space. And then connectivity, here we are going to each row as well as column, we are going to give a space. See, in the first one is acyclic graph structure. Here we are specify total 6 nodes we have in the acyclic graphs are available in the Gestalt perception. The second one is acyclic graph is not available in the second one. Triangle shapes we are specified. Here we are don't have a acyclic graph. Only the directed edges we are using every both the places. But in the first one diagram, we have an acyclic, but second one is we don't have that much acyclic graph. Ecological theory of perceptions. In the ecological theory of perceptions, first one is fundamental hypothesis. Here we are going to find out. Here in images we have the bird is travel different directions, the in a sphere in different directions, traveling. It does not travel the same directions. See, correlation between the organism and its environment. Here we are taken an behavioral pre-adaptations. So the ecological optics, that is here we are specified. So the moving object, the motion may be different directions in an object. It's not a similar all the time an object. Action perception coupling, that it's we are going to affordness. Here we are taken as Hicks laws and Fitts law, empirical laws extracted from controlled observations. Here, first one is Hicks laws. We are going to take time is take to select an item in a set of in a set. That is an equation. RT gives a plus b log base 2 of n. A and b are here taken as a constant. N is the number of items. See, A and B are a constant. N is the number of items. We are going to iterate. So to select an item in a particular set, so we are going to take, we use a Hicks law. And similarly, Fitts law, time it takes to acquire a target. Here, select an item. Here, acquire a target. So Hicks law is going to select a particular item. Here, Fitts law, acquiring a target of a particular object. So here, MT is equal to A plus B log base 2 into 1 plus D divided by W. That is here, A and B are both similar constant. D is the distance to a target. That is the amplitude of the value, D. And the W is equal to pointing the tolerance, that is width of the target. So the previous slide we are discussed. Now the motion width is maybe differ. So the motion pictures, the same width or different width is we are going to follow or not. So the distance target we are going to take in amplitude. Similarly, with W is equal to pointing the tolerance, that is the width of the target. So this law is valid only precise experimental settings only. So next one is we are going to discuss kinematic chain theory. So here some example we are going to take in. Classical psychology, the left hand side is bad right hand. So the two hands have different role. So in actual, we are going to travel a bike. So in the first left hand side, we are going to apply the brake and other things. On the right hand side, we are going to accelerate the two-wheelers. Similarly, in four-wheeler, we are going to use similarly the applying for the brake and accelerator. We are going to on right hand side, and then clutches we are going to apply in the left hand side. So that thing is left hand and bad right hand. Left hand is a bad right hand in a classical psychology. Here also we are going to take up kinematic chain theory. Non-dominant hand distortional control. Act first, establish the frame of reference for the dominant hand. See, dominant hand proximal control, non-dominant hand distal control. So non-dominant hand is distal control, dominant hand is proximal control. So non-dominant hand is act first, establish the frame of reference, that is for dominant hand to the next level. Act first, act after, then non-dominant hand. So non-dominant hand is first execution. After that, dominant hand will be executed. See here, falsification. Some tasks are more efficient when the hands have symmetric roles. See here, the next one is cognition and behavior, action theory, Norman, situation the action, Suchman, activity theory, Vittrozi and Bodker, and cognitive dimension and Green. So the authors are represented action, situation, and activity theory as well as actions in the dimensions. See here, in the action theory, the diagram represents the goal we are going to achieve. So intention, specification, specific action, execution, system, perception, interpretation, and evaluation, we achieve the goals. See here, the execution distance and the evaluation distance in left as well as right hand side. Respectively. Articulatory cognitive distance, articulatory input distance. Similarly, output cognitive distance, output articulatory distance in left hand side as well as right hand side. In the action theory, we are going to take up. So intention, specific action, execution, then perform the system, perception, interpretation, evaluation, we reach the goal. So output cognitive distance we are find out. Next, situation action, situated action. So here, classical cognitive approach we are going to take up. Cartesian models where all actions are we are going to plan and human actions are explained by the cognitive process. Action theory, task analysis, mental models, we are going to an example for situated actions. Entomological entomethodological approach here. Work practice in order to determine causal chain implies observed actions or we are going to take up. And then situated actions, human can play a vital role based on the context, depend on the actions we are going to take up in that particular place or role we are applying for the situated actions. And the level of activity we are going to take up, three question marks we are going to take up. Activity, so why, what, how. So why, respond to a need, that is activity we are going to take up. So action, executed continuously to reach the particular goal by to set by the subject. And how, executed unconsciously or semi-consciously to executed an action. This is for the level of activity, why, what, how we are take up. Activity theory, the level of activity, how, why, what, how we are applying. Same thing, action, operation, activity we are going to take up. Here, the triangle is represented. So outer triangle is represented division of labor, role, instrument. Here, totally 5 triangles are we have. So subject, rule, community. So this is one action we are going to perform the operation. Similarly, object, community, division of labor, another action. Subject, object, community, another triangle. So instrument, subject, object, another triangle. So the overall results we are going to take care of: action, operation, activity. So the automation, conceptualization to achieve the context in the activity theory. Next one is cognitive dimension, notations. In the notation to help designers and evaluating the certain criteria based on the conditions. Similarly, to solve us particular problems, here we are going to specify 6 type of activities: incrementation, transcription, modification, exploration, search, and comprehension. So first one is incrementation. So we are going to adding some particular set of data in a specific activity, and then source to destination values we are going to transcription, and then updations we are going to taken up the source to destination content we are change it, and then we are given trial and error, that is give a solution for a modified content for that new solution we are going to give. And then finally give a unknown aspect of the system, we give a new solution, discover new things. Here dimension aspect of the informational structure that can be analyzed according to the activity being studied. Here some examples here we are given: viscosity, visibility, premature commitment, hidden dependencies, role expensiveness, abstraction, consistency, and also more things are here we are having in cognitive dimensions. And then interaction morphological analysis of input devices, UAN, Cord and et al., and UAN Hartson, and Straight Machine Newman, GMOS Hordman Newell, instrumental interaction, Budon, Laffan. The authors are specify the interaction areas. So morphological analysis of inputs. Here, description of the properties of an input device, transducer. Given an example here, transducer of physical properties into a logical properties. Here, M is denoted as a manipulation of operation. So here, position or force, absolute or relative. So position is indicated P, force is indicated as F, absolute dP, relative as dF, linear or circular, it is specified uppercase X, Y, Z, similarly, or small or X, or Y, or Z, respectively, it is a linear as well as circular. So input domain is indicated as IN, S is indicated as current state of the device, R is indicated as resolution function, that is input to output. Output domain, out is indicated. W is specified other properties of interest. See here, composition of input devices, the pictorial diagram is given. So different nodes are connected. The line is indicated, dark line is merge. So this is for merge. And then dotted line is layout line. Two line is indicated as connect. So merge, layout, and connect. Composition input devices is different nodes are connected to a single node. So that is we are going to morphological input device as well as output device process. User action notation here, action and system responses we are taken. So action and system responses is here, action as well as the feedback. So we are given a MS, we are specified. M is the manipulation of the operation. So here icon as M is indicated. So what is the output we are receive? Similarly, how many operations we are going to perform? So indicated as all of the operations, icon indicated whatever the operations we are specified, all the operations are here we are specified. Moving an icon, a file icon, what are all the file icon, and then what are the output line is specified at the outputs, specified outputs. See here, move file icon, operations, what are all the input, what are all the output actions we are specified, what file we are going to, we are selected in the interface state, and then final output we are receive in the computation space. That is a user action notation. Informal notations usable with the standard keyboard and easy to remember. And in new symbols, new columns, these are all the examples for we are using user action notations. And in GMOS family of models, GMOS is goals, operators, methods, and selections. The first letters is we are indicated as GMOS: goals, operators, methods, selection rules. Goals, what the user want to do. Operators, action supported by the software applications. Methods, learn sequence of sub goals and operators to reach goals. Selections, what are all the rules we are going to apply in personal as well as kind of methods. And then GMOS is both a method to describe the user task, a set of descriptives. And then here GMOS models are task analysis techniques based on a model and information processing. Here, keystroke level modeling in the 6 operators in the original version, KPHDM. So KPHDM is hit key, pointing the target, homing, drawing a line segment, mental activity to prepare for a next action. See the actions, each operators having some specified time durations. So here indicated H is 0.08 second to 1.20 second, that is the mean of the value 0.40 seconds. Pointing the target with the mouse 1.10 seconds. Homing is 1.00 seconds. And then drawing a line segment 0.9 into 9 plus 0.161 n segment long, and then next action is 1.35 seconds. So magical rule is applying for in M, mental activity for preparing the next action. So the method 5 and 3 here we are going to apply the selection, copy command, select destination, paste destination. That is select the content, copy the content, that is source destination to target destination. So here MPK, that is a P pointing the target, key is a hit key. So M is here mental activity to prepare for the next action, pointing a target with the mouse, hit key or a button. So how many pointing target with the hit key? So here copy command, more than one hit key as well as pointing target we are taken. Source destination to target destination. Total duration is here we are calculated 14.9 seconds. So the hit count as well as pointing the target, and then homing, that is a moving hand between the mouse and the keyboard we are taken. And then Codman Newell GMOS evaluation of the keystroke level. Some additional operators we are going to take in. The computer support, automatic evaluation of predicted time, automated evaluation of selection rules, and predictive models here we are going to take up. So here operators have some fixed durations, or learning is not taken into an account. So next one is instrumental interaction models. Here interaction in terms of domain object and instrument, action, reaction, operation, and the response. Here we receive a feedback: action, reaction, operation, response, then finally we receive a feedback. See here descriptive aspect, predictive aspect, generative aspect. These things we are discussed in action theory. So descriptive, predictive, and generative theories. And then software architecture model, SAME and MVC and PAC. So SAME is a presentation of an content, that is we are going to fetch new image or objects. See here presentation, managing input and display at a low level. Here dialog control, functional core interface receiver new data. Then MVC already we known, model view controller. So model is a abstraction of an object, interactive object. View is a output, that is end user viewing. So controller is activating the model as well as the view. So it is implemented Smalltalk system also. And then in the model view see domain specific component, domain adapter component, dialog component, presentation component, interaction component. See the model version of SAME. See the presentation, dialog control, functional core interface, and functional core. See these are all the thing is represented in a architecture. Acknowledge the existing user interface toolkits. That is we are going to use in different type of adapters as well as functional core sites. So presentation abstract control, here we are going to construct a different type of tree agents, different facts we are going to specify here. Heuristic structure of the tree in different multiple views we are going to use in presentation abstract control. In the presentation abstract control, we are combinations we are maybe apply in different ways. So that is A-star algorithm, we have genetic algorithm we are used. Like a presentation abstract control, we are going to use. Conclusion: in model and theories and human-computer interactions, borrowed from the psychological, action, perception, cognition, and also sociology and entomology, borrowed from the computer science, automata theories, and specific to genus and instrumental interactions. It may be helpful to you to find out theories and models in human-computer interaction. Thank you.